33. Let's take a look at question number 1. A particle P of mass m is attached to one end of a light inextensible string of the length a. The other end of the string is attached to a fixed point O. The particle moves in a horizontal circle with constant angular speed omega and with the string inclined at an angle theta to the downward vertical. Given that the tangent theta is equal to 4/3, find omega in terms of A and G. So over here, I usually will need to draw a diagram. So this is the theta, and this is the circular motions. We have a tension here, T. We have the weight, mg. Okay. And we're having circular motions. So first of all, we start from the tangent theta is equal to 4/3. This will give you that we can draw a right angle triangle so that we can build a right angle triangle here by using Pythagoras theorem. Okay, so now we resolve the forces vertically. I have the d cos theta is equal to the mg. And since the cos theta is a 3/5, therefore we have d is equal to the 5/3 mg. That will be the equation number 1. Then I resolve the forces horizontally. I have the d sine theta is equal to the mr omega square. We're looking for the angular speed. So the r is actually, this is length a. So it will be d sine theta equal to the ma sine theta omega square. This one can cancel. Then your t is equal to the ma omega square. That will be your equation number 2. Let them equal. You will have 5/3 mg equals to the ma omega square. The m cancel. Therefore, your omega is equal to the square root of the 5g/3a. Done. This will be the answer for the question number 1. So move on. We have question number 2. Attached to one end of a light elastic string of a natural length a and the modulus of elasticity mg. The other end of the string is attached to a fixed point O on the rough plane inclined at an angle 30 degrees to the horizontal. The particle is held at rest at the point O before being released. Then the frictional force acting on P as it slides down the plane is 11/30 mg. Find in terms of A the distance of P that move down the plane before it comes to rest. Okay, so over here, we will need to have a diagram. At first, you are at here. Then after that, when you release from rest, it will go down because of the gravitational force. And it stretch until the X and the A. So at the beginning, your U is at 0. For the particle to come to rest again, that means the V over here will also be 0. So that means the kinetic energy at the beginning and the kinetic energy at the end all are 0. Okay, so this is what we need to know. Maybe let me draw the diagram that looks better. So this is the A. This is the X. That is your P. Okay. So now, we need to use conservation of energy. But first of all, we need to find the height. So the height, this is A plus X. So we know that the height is actually A plus X sine 30 degree. That will be half of the a plus x. Okay, so we get this one ready. Now we can just direct do the conservations of energy, COE. So it will be the GPE loss is equal to the EPE gain plus the work done by the resistant. Okay, so your formula will be the MGH equal to the lambda 2L of the x2 square minus the x1 square plus the FR multiplied by the distance traveled. This is the formula. What is the H? H we have just found just now. This is the H. So we just put the H inside. What is a lambda? Lambda is a modulus of elasticity. It's given as mg in the questions. Your extension is x squared. At the beginning, you have no extension. Frictional force given in the question is 11 over 30 mg. And the distance traveled is a plus x. Okay, so this is what we need to build for the conservation of energy. So you can see that all of them have mg. All the mg can be cancelled off. So we have a half a, we have a half a plus x is equal to the x squared over 2a. And then plus the 11 over 30. Okay, so this is what we have. And we can actually join together. Or maybe we don't need to join together. I multiply everyone by the 30a. I will get this one as a 15, 15a, a plus x. Multiply everyone by 30a. Then I get this. So this one I get 15x squared. This one I get 11a, a plus x. So over here I get a 4 joined together. Then I get 15x squared minus the 4ax minus the 4a squared equal to 0. So we try to factorize it. So we have a negative 2a, positive 2a. A equal to the negative 2a over 5 and x equal to the 2 over 3a. This one rejected or ignored. Okay, so but we are looking for the distance. We're looking for the whole distance from the O. Okay, distance that B moved down the plane. Okay, so the A plus X. So the distance is equals to A plus X is equal to the A plus 2 over 3A. That will be equals to the 5 over 3A. Done for this questions number 2 part A. Done. Okay, so now we move on to the part B. It is given that the B remain at rest at the new positions. Find in terms of M and G the magnitude of the frictional force in these positions. So now the questions mention that after B reach here, which is a plus X, okay, after the B reach over here, then it's at rest. So over here, your D is tension, okay, your tension. Then you are having R over here, you are having a mg over here, What about your frictional force? Because the surface is rough, so you need to have a frictional force. The frictional force, you are having the string is actually have an intention to pull the object goes up. And then that means the frictional force will actually go this way. Okay, so if you resolve the forces parallel to the plane, you will have T is equals to the mg sine theta plus the Fr. Okay, and then the T is actually lambda x over L. And the theta is a 30 degree. Lambda is given as mg. X, just now we found x is a 2 over 3a. L is a. This is the half mg. So your Fr will be equals to the 2 over 3 mg minus the 1 over 3 mg. 1 over 6 mg. Okay, so that will be your frictional force. Done. This will be the answer for number 2B. Now we move on. Question number 3. Have a ball of mass 10 kg projected vertically upward with the initial speed of u meter per second and move under gravity. As time t second after the projections, the ball has traveled the distance and is x meter and the speed is v meter per second. There is a resistive force of a magnitude mkv square. K is a positive constant. Show that the distance traveled by the ball is moving upward with these equations. Okay, so if you resolve the forces vertically, you are having the negative resistant force is equal to the MA. That will be negative mkv square equal to the MA. Cancel the M, you get the A is equal to the negative. Okay, sorry, I make a mistake. This is wrong because I forgot to consider the weight. Okay, so if you're going upward, you have a negative mg minus the frictional force is equal to the MA. It will be negative mg minus the mkv square equal to the MA. M cancel. So you have a A is equal to the negative of a G plus the kv square. Okay, so you're looking for X in terms of the V. So I need to convert my A as a V dV dx equal to the negative of a G plus the kv square. So just do the separable variables. Then you get this. Negative dx. So just integrate using the formula correctly. I'm using the f prime over f formula. Using this formula to integrate. So I will get this one as the 1 over 2k ln modulus over g plus the kv square equal to the negative x plus c. Okay, so given when at the beginning, the speed is a u. So you have a c is equal to the half k ln g plus the ku square. Okay, so this is the c constant, and we replace the constant back over here. Then we can find the x. So you have a 1 over 2k ln modulus g plus the kv square is equal to the negative x plus 1 over 2k ln modulus g plus the ku square. So the x, it will be equal to the 1 over 2k ln over g plus the kv square, ku square. Minus the ln of the g plus the k v squared. Join together by the law of logarithm. This is what we have. But the questions over here, they just use bracket. They didn't use modulus. Okay, so we can just use the good. What is the reason we changed the modulus to bracket? Actually, everything is all positive. So all positive, there's no need to put modulus anymore. Okay. So shown, done for the part A. Then now move on to the part B. It is given that the K is equals to the 0.025 and the U is a 20. Find the time taken that the ball to reach the maximum height. So given K is equal to 0.025, then the U is equal to 20. So we will be U is a 20. Okay. But we need to find time. T and X. Oh, maximum height, sorry. If they're looking for maximum height, then the V will be 0. Okay. Since I know the U is a 20 and the V is a 0, when you reach the maximum height, then we can find the time. So now what you need to do is we will repeat again the result that we have just now. In the part A, this result, we start from here. Changing the K to become 0.025. Then you change the A, become dV dt. This, you will get time. This is actually 1/40. Okay. We can make it become 100 plus the V squared over 40. So your dV, it will be this. Okay, so this one, just check the formula booklet, MF19. You can see that it will belong to the 1/20 arctangent of the V over 20 equal to the negative T plus C. So you will have 2 arctangent of the V over 20 equal to the negative T plus C. Given that when the T equal to 0, your initial speed U is at 20. So you will have 2 arctangent of 20 over 20 equal to the 0 plus C. So your C is actually pi over 2. So replace the C back, you will get 2 arctangent of the V over 20 is equal to the negative T plus the pi over 2. Then when you reach the maximum height, your V will be 0. So it will be 2 arctangent of a 0. Therefore, your T will be pi over 2. Second. Okay, done. So this will be the answer for the question number 3B. Okay, number 3B. Yeah. Okay. Moving on, we have question number 4. The object consists of a uniform lamina, with a particle attached. There's a particle attached here. The uniform lamina A, B, C, E, F, D of the mass M is formed from the rectangle ABCD and isosceles triangle CEF, where F is a midpoint of the CD, and the rectangle has a side of 2A, AB is equal to 2A, and then AD is equal to A. The triangle CEF has the base of A and the height of 2A. Everything is already given in the diagram. Okay, everything already given in the diagram. Okay, so nothing special over here. We just need to, based on the diagram, we want to find the center of the mass of the shape. Okay, given that the object is on the point of toppling in the vertical plane above the vertex D, find the value of K. So if you at the point of toppling, that means your center of the mass is actually here. The center of the mass is actually here. Then so that it will be toppled. Okay, it's at the point of toppling. Find the value K. So over here, we just need to consider the lamina. Okay, without the particle. So we just need to build the lamina only. Since it's using the same material, we will consider the area. We have a rectangle and we have a triangle. So this is the combined lamina. So the area for this one is rectangle is a 2A square. The area for the rectangle is half times the base times the height. It will be the A square. Total, you have a 3A square. So now we want to find the center of mass. Over here, I will okay. So that means what I need to do is at first, no particle. Because this question is mentioned that with the particle attached over here, then it will, at this point, it will become topple. It will at the point of toppling. That means without this particle, that means the center of the mass may not be here anymore. The center of the mass may be somewhere here. Okay. So over here, if you measure, it will be bar X. I do not know the value. I just call it bar X. So over here, the center of the mass I want to measure from the AB. Measure from AB, Okay, so from AB, so if you measure from AB, the rectangle is actually half of the A. For the isosceles, it will be the A plus the 1/3 of the 2A. So this will be 5/3A. And this will give you the bar X. Oh. This is a 2A. Okay. So you just need to find the moment, take the moment. Down the AB. So you will have a 2A square half A plus the A square 5/3A is equal to the 3A square bar X. A square cancel. So you have A plus the 5 over 3A is equal to 3. So your bar X, it will be equals to the 8 over 3, 8 over 9A. Then now with the particle attached, if you have a particle attached, 8 over 9A is here, because this one is less than A. So your center of the mass for this lamina is actually here, mg. And you have a particle here, kmg. So the moment, the center at the end, the center of the mass will be here. So if you take the moment about the line CD, that will be equals to the mg multiplied by the distance over here. Perpendicular distance is actually A minus 8 over 9A equals to the kmg multiplied by 2A. So over here, you can cancel the mg. You can cancel the A. So you have a K is equals to the 1 over 8B. Okay, so this will be the answer for the question number 4. Done. Okay, so now moving on, we have question number 5. F, the hollow cylinder of a radius r is fixed with the axis horizontal. Point A, B, and O are in the same vertical plane perpendicular to the axis of the cylinder. A and B on the smooth inner surface on O and O on the axis. OA and OB makes an angle 90 degree and alpha respectively with upward vertical through O. With A and B opposite sides of the vertical, a particle of mass m is projected vertically downward from a point A with a speed of a square root of 3 over 2 rg. Move in a vertical circle inside the cylinder. The particle lost contact at the point B. Find the value of alpha. So what you need to do is conservations of energy. So we just direct start from conservations of energy. We have the GPE loss, GPE gain, because you're moving from A to B. It will be equal to the KE loss. So it will be mgh equal to the half m of the u square minus the v square. So you will have v square is equal to the u square minus a 2gh. So your u is given as this. So it's a 3 over 2 gr. Your h is over here. This is the h. So your h it actually will be r cos alpha. So it's a 2 gr cos alpha. So I call this one equation 1. And at the point B, if you resolve the forces to the center, you will get the R plus the mg cos alpha is equal to the mv square over the R. Given R equal to 0, lost contact. So that means the v square is equal to the gr cos alpha. That will be your second equations. Let the equation 1 equal to equation 2. You will be having the 3 over 2 gr minus a 2 gr cos alpha is equal to the gr cos alpha. Cancel the gr. You get cos alpha is equal to half. So your alpha is equal to 60 degrees. Done. So we have done the answer for the part A. Now move on. We have a part B. Find the subsequent motion. In the subsequent motion, find in terms of R, the greatest height above O reached by the particle. So when you reach over here, your V, you do not know yet. And the angle over here must be 60 degrees. And you're moving in the projectile motions. Okay. And you are looking for the greatest height. This is the maximum height. This is the center of the circle. This is the R cos alpha. So the maximum height need to be calculated from here and this add together. So first of all, we need to find out the V square. Okay. So when your alpha is equal to 60 degrees, my V square is equals to the GR cos alpha. Okay. V square is equal to GR cos alpha is equal to the half GR. So if we want to find the maximum height for the projectile motions, if we consider the vertical motions for the projectile motions, so we will be having the W square is equals to the V sine alpha square minus the 2GH. Okay, if we consider only the vertical motion, because your V square is half GR and your angle is 60 degrees. So we consider the vertical motions. We only consider this vertical motion. It will be the V sine 60. V sine 60. So it will be when you reach to the maximum height, you have a 0 is equals to the V square sine square 60 minus a 2GH. So what is a V square? The 2GH will be equals to the V square just now we know is a half GR. Then sine square 60 is a 3 over 4. So you have the G and G cancel. You have the H is actually 3 over 16. Your maximum height above O, it will be equals to the R cos alpha plus the height that we have found just now. So it will be half R plus the 3 over 16R. Add together, you get 11 over 16R. Okay, so that is the answer for the question number 5B. Move on. We have question number 6. Two identical uniform smooth sphere A and B with each the mass is m, moving on a horizontal surface with the speed of 2u and u respectively. They collide. When they collide immediately before collisions, the spheres are moving parallel to each other in opposite directions, such that their directions of motion makes an angle theta with the center. As a result of the collision, B move in the directions which is perpendicular to its initial motion. Coefficient of friction between the sphere is E. Find the expressions for tangent theta in terms of E. So we need to draw the diagram for before and after. Before, the A is moving this way. This is the 2u. And the B is moving this way. This is also a theta. This is the U. This is the M. After the collisions, we do not know the A directions. We just simply take a guess. I call this one alpha. But the B, they say it rotate 90 degree. So if it rotate 90 degree, that means it will be here. So just now this was theta. That means now this is the theta. Okay, after the collision, this is the theta. We do not know the speed of the V, of the B, we just write VB. Okay, so this is the what we have. M and M. So we start from the PCLM, principle of conservation of linear momentum. You have a M 2U cos theta plus the M of a negative U cos theta is equal to the MVA cos alpha plus the MVB sin theta. So we cancel all the M, join together. We have a VA cos alpha plus the VB sin theta is equals to the U cos theta. That will be my equation number 1. After that, we apply the Newton experimental law. We have a E equal to the negative of the VB sin theta minus the VA cos alpha divided by negative U cos theta minus the 2U cos theta. Then cancel the negative, you get the VB sin theta minus the VA cos alpha is equals to the 3EU cos theta. That will be my second equation. Take the equation 1 plus with the equation 2. You can cancel the VA cos alpha. You will get 2VB sin theta is equals to the 1 plus 3E U cos theta. Then you get the VB sin theta is equals to the half of 1 plus 3E U cos theta. This one I call it equation number 3. Now at B, if I consider the one that is not involved, the directions of the component of the velocity that is parallel to the collision, that means this. Oh, no, sorry. The parallel that is not involving the collisions, that means this vertical, which means that for the B, before and after the velocity component, the component of the velocity is the same. That means the U sin theta is equal to the VB cos theta. So you have a U sin theta is equal to the VB cos theta. So that means the VB cos theta is equal to the U sin theta. That will be the equation number 4. We're looking for tangent theta. So what you need to do is to take the equation 3 divided by equation 4. 3 divided 4. So you will get the VB sin theta divided by VB cos theta is equals to the half 1 plus 3E U cos theta divided by the U sin theta. The U can cancel. VB cancel, the U cancel. You actually have tangent theta equals to the 1 over 3 plus 1 half plus 1 plus 3E cotangent theta. Cotangent theta is 1 over tangent theta. Bring it to the other side. You get tangent square theta. So your tangent theta is actually positive square root of 1 plus 3E over 2. Done. This is the answer for the questions number 6A. Okay, so now we move on. 6B. As a result of the collisions, A move in the directions which is perpendicular to the line of center. So perpendicular to the line of center, that means after the collisions, A, okay, maybe we can consider before the A is moving this way, theta. Then after the collisions, the A is moving perpendicular to the line of center. That is your VA. Okay. So that means the assumption that I have just now, was wrong already. Because alpha is 90 degree, cos alpha will be a 0. Cos 90 degree will be a 0. So we only consider before and after. These two are the same. Okay, so if we consider these directions of the velocity, you have a VA is equal to the 2u sine theta. Okay, and just now, we have the equation 1. Equation 1, we can straight away replace the alpha equal to 90 degree over here. And also, we can straight away replace. So actually, we do not need this information. Never mind. From equations 1, you have equation 1. I forgot already. Sorry. Equation 1 is these equations. 0 plus VB sine theta equal to the cos theta. VB sine theta equal to U cos theta. This is not needed. This is not needed as well. This is not needed as well. I just need to take the equations. We just say that when alpha is equal to 90 degrees, just now the diagram, because the A, just now in the part A, I make an assumption that after the collisions, okay, just now I make an assumption in part A, the angle is alpha. Okay, so when the alpha is equal to 90 degree, from the equation 1, you get the VB sine theta is equal to the U cos theta. Then the equation number 2, you have a VB cos theta is equal to the EU EB cos theta. Equation number 2. Equation number 4. VB cos theta. Equation number 4. So the VB cos theta will be equal to the U sine theta. That will be equation 5 and equation 6. Take the 5 divided by 6. You have a tangent theta equals to the cotangent theta, which means that the tangent square theta is equal to 1. That means the tangent theta is equal to 1. Tangent theta is positive. So therefore, your theta is a pi over 4, 45 degree. Or maybe we write 45 degree. Okay. So this is the answer for the question number 6B. Done. Now we move on to the question number 7. Projected from a point O with a speed u and an angle 45 degree above the horizontal, move freely under gravity. State the vertical and the horizontal component of the velocity at time t. So for the horizontal component, for the vertical component, you have the uy is equals to the u sine 45 degree minus the GT. We can make it become Z2 over 2U minus the GT. Then for the horizontal component, it will be the UX is actually U cos 45 degree. So it will be Z2 over 2U. That is your UX. Okay, done for the part A. Now move on, we have a part B. At the time T, particle P move at the angle 60 degree below the horizontal. Show that the D equal to this. So when your T is equal to D, so my UX will be equals to the Z2 over 2U minus a GT. My this is a UY. Then the UX is equals to the square root 2 over 2U. Okay. So your tangent alpha is equal to the UY over the UX is equals to the Z2 over 2U minus a GT divided by the Z2 over 2U. Then given alpha is a negative 60 degree because this is 60 degree below the horizontal. So tangent negative 60 degree will be equal to the Z2 over 2U minus a GT divided by the Z2 over 2. So this one is a negative Z3 multiply Z2 over 2U equal to the Z2 over 2U minus a GT. So we can actually combine them together. So we have 1 plus Z3 Z2 over 2U. So the D is equal to the 1 plus Z3 Z2U over 2G. Multiply the Z2 inside, you can get D equal to the Z2 plus Z6 U over 2G. Shown. This is how you show the result. Okay, for the number 7B. Now move on. 7C. At the time T, the particle strikes a smooth horizontal plane at a point which is horizontal distance D from O and the vertical distance H below O. Find the ratios of H to D. So we need to have a diagram. At first, you project it with the speed of U and with the angle of 45 degree. So you project it, then after that you drop down. When you reach over here, this is a 60 degree. The angle over here is 60 degree. And the distance over here is D. And the height over here is H. Okay, this is what we have. Then we need to use the horizontal displacement formula. X is equals to the U cos 45 degree T. Okay, so when the D is equal to D, your X is equal to D. That means the D is equal to the Z2 over 2 U times D. Based on the result that we have just now, the D is given as the result in the part B. The D is given as a Z2 plus a Z6 over the 2G U. So it will be 1 plus 3, 2g, and u squared. That will be the d. Then for the vertical component, your y is equal to the u sine 45° t minus a half gt squared. When the t equal to t, uppercase t, your y is a negative h. So it will be negative h equal to the u sub 2 over 2. T will be this. Minus the half g t squared. The t will be sub 2 plus sub 6 over 2g. And then the whole thing square. So this one have to be careful. You will get this one as the 1 plus the 3 the 2g u square minus the g over 2 have to be carefully expanded. 2 plus 6 plus the 2 sub 12 divided by the 4g square and u square. So over here you will have 1 plus 3 this one you will get 8 plus 2. So you will get this. I think we better simplify the thing inside the bracket. You have a 8 plus the 4 sub 3 over the 4g square, the u square. Almost done. Simplify it, you will have 1 plus the 3 over 2g u square minus the 2 plus the 3 divided by 2g u square. Simplify it together. You will have this one as the negative 1 over 2g u square. That is a negative h, which means that your h is a positive u square over 2g. So therefore, h over d is equal to the u square over 2g divided by the 1 plus the 3 over 2g. U square. Cancel it. You get h to d is equal to the 1 to 1 plus the 3. That will be the ratio of h to d. Done for the question number 7c. Move on. We have a 7d. After strike the horizontal plane P rebound with the speed W and the coefficients of restitution between the P and the plane is 2 over 3. Find W in terms of U. Okay. So over here, after rebound, we need to draw a diagram, because when you hit to the plane and you rebound, so this angle just now is a 60°. And you rebound it with the speed of W. Okay, so this speed I call V. And I can, the V, this is a 60°. This is the W. This angle is, actually we do not know. So we know that this and this it remain the same. Okay, so this one I call it the, if we consider the horizontal, you have the V cos 60 is equal to the W cos alpha. So your W cos alpha is equal to the half V. And if you consider the vertical one, you will be having collisions involving collision have a rebound. E is equal to the W sine alpha over the V over to the V sine 60. So this one, it will be W sine alpha is equals to the 2/3 V sine 60. So you will get the 3/3 V. Okay. Your W square, I call this one equation 1. I call this one equation 2. So just take the equation 1 square plus equation 2 square. You will get W square is equals to the 1/4 V square plus the 1/3 V square. So you will get 7/12 V square. But we do not want V square. We want U square. We want in terms of U. So we need to find the V. We need to find the V. Okay. So the V is actually equals to the V square is actually equal to the UX square plus the UY square. That means we will need to take this result. We need to take this result. You square it. Okay. So that means when T is equal to the your UY is equals to the sec2/2U minus the GT. T just now already shown is a sec2 plus a 6/2G multiplied by U. So you join together, you will get this one as the negative 6 over 2. Okay, that is your UY. Your UX will be the sec2/2. So the V square is equal to the UX square plus the UY square. It will be equals to the 2/4U square plus the 6/4U square. So you will get this one as a 2U square. Okay. So I call this one equation 3. I call this one equation 4. So W square 4 into 3. W square is equal to the 7/12. 2U square is equal to the 7/6U square. So therefore, your W is equals to the square root of 7/6U. And this will be the answer for the question number 7. And this will be the last question for this paper. So I'll stop the video. I'll see you next time. Bye-bye.